Welcome. Thanks for joining us. Today we'll be talking about the Illicit Connection and Illicit Discharge Field Screening and Source Tracing Guidance Manual. We'll be providing an overview of the manual and its content, and also focusing on what some of the new updates are in the 2020 manual. My name is Rebecca Dukopolsky. I'm an associate engineer with Herrera Environmental Consultants. The outline for today's training includes an introduction and talking about manual structure and content. We'll be starting off with a warm-up exercise, followed by the manual overview and focusing on key updates. We're focusing on sections 3, 4, and 5 of the manual, which include field screening methodologies, illicit discharge indicators, and source tracing methodologies. So starting off with our warm-up exercise, we're going to have some definitions that we start with, and then we'll walk through some examples of what illicit discharges are and what they are not. So our first question here is, what does illicit mean? Something that is not allowed, something that is unlawful or negligent, or breaking social norms. And unlawful behavior may be unintentional, so you may not know, someone that's discharging may not know that they're causing an illicit discharge to happen. Illicit connections are defined in the Phase 2 permit and also in the Phase 1 permit as any infrastructure connection to the Municipal Separate Storm Sewer System, or MS4, that is not intended, permitted, or used for collecting and conveying stormwater. You'll notice there's a few dots at the end there, and we'll be talking about what some conditionally allowable discharges are in a minute. But illicit connections include sanitary sewer connections that are connected to the storm system, and also things like interior floor drains that might be misconnected to the storm system as well. The permit defines illicit discharges as any discharge to a MS4 that is not composed entirely of stormwater. And again, you'll see the dots there. We'll be talking about those conditionally allowable discharges in a minute. Some examples of illicit discharges include industrial process water, spills and illegal dumping, and car washing. And you'll notice the picture here, this is a good example of illegal dumping, someone that was striping a parking lot and then had some extra paint left over and just dumped it in the nearby catch basin. So now we have a series of slides we'll run through of what are illicit discharges and what are not. So the first one is water from roof drains. Do you think that's an illicit discharge or not an illicit discharge? Hopefully you're shaking your head. So the answer is no. So generally, runoff from rain on roofs is not considered an illicit discharge. There are a couple caveats in the permit. If you have a larger roof that's metal and it's uncoated, or if it's a roof that's subject to venting significant amounts of dust, mist, or fumes, that may require some additional water quality treatment. But generally, as in the picture you see here, a standard residential commercial roof would not be considered an illicit discharge for the water coming off of that. What about water from firefighter training? And the key word here is training. So hopefully you're nodding your heads at home. And the answer is yes, if foam is used. So if it's just general water that's during firefighter training, it's not an issue. If foam is used, that does have to be captured and disposed of properly. Another thing to think about here is during an emergency response, so actually fighting a fire, that would not be considered an illicit discharge because that's something where emergency response is the key priority, not stormwater in that case. What about wash water from a charity car wash? Do you think that's an illicit discharge or not? Okay, hopefully some nods at home. So yes, unless it's directed to the sanitary sewer. There are some good car wash kits out there that you can now direct that water directly to the sanitary sewer. So there's a way to do a charity car wash in a regular parking lot. And a lot of jurisdictions have also set up a separate car washing station for charity car washes. So that's a great way to prevent that water from getting into the storm system. What about basement sump pump water? Do you think that's an illicit discharge? So answer here would be no, unless groundwater is mixed with sewage. So sometimes we have issues in our basements that cause sewage overflows, and then that could be considered an illicit discharge. But generally your sump pump should be just taking groundwater out of your basement, so that would not be considered an illicit discharge. What about fire hydrant flushing? Do you think that's illicit or not? So this is an interesting one. This is one that's on our conditionally allowable list. So if you were just flushing a fire hydrant and you weren't doing anything with that water, that would be considered an illicit discharge. But if you're dechlorinating it to less than 0.1 parts per million, if you're pH adjusting it if necessary and controlling the volume and velocity, then it's not considered an illicit discharge. But all those things need to be met. So you'll notice here you would need to put some sort of dechlorination system onto the fire hydrant before you're flushing to make sure that you're taking care of that water and dechlorinating it. So similar issue with swimming pool water or also spas and hot tubs. Do you think that's an illicit discharge if you're just flushing out your swimming pool, cleaning it? So again, that's a conditionally allowable discharge. So that's a large volume of water. So you'd have to take a look at that and make sure you're dechlorinating it to that 0.1 parts per million or less, adjusting the pH, and then controlling the volume and velocity. What about construction dewatering? Do you think that's an illicit discharge or not? So this is one, if you're meeting certain criteria listed in the permit for pH and total settleable solids, it wouldn't be considered an illicit discharge, but you do need to make sure that you're meeting those criteria. And then the last, two more left. We've got wash water from buildings and sidewalks. What do you think about that? Is that considered an illicit discharge? Here you can see this person's using quite a bit of soap. You can see kind of the soap on the street here. So if you're not using soaps or detergents, it is allowable. But if you're just spraying down a building or not, or something like that, and not using detergents or soaps, then that would be acceptable. What about lawn watering? This is kind of an interesting one. So it is listed as conditionally allowable in the permit, and that's because the discharges should be minimized through public education activities and water conservation efforts. But oftentimes we see sprinkler heads that are misfocused and things like that, where a lot of that extra water is just running off into the street. So making sure that we're watering appropriately is kind of the main concern here. The next we're going to shift to an overview of the manual. The manual was originally developed in 2013. It was funded by a grant of regional or statewide significance from the Department of Ecology and was updated in 2020. And that was overseen by the Source ID subgroup. That's part of the Stormwater Work Group, which is part of the Stormwater Action Monitoring Program through the Department of Ecology. The scope of the manual focuses on field methods for field screening and source tracing of illicit connections and illicit discharges. So that's where that term ICID comes from, which is different than the term we see in the permit, which is the IDDE, which also focuses on elimination and enforcement. So instead of using IDDE, since we're not really focusing on elimination enforcement side of things, we just clip that off and we're focusing also on illicit connections and illicit discharges, which is why we use ICID as our umbrella term for the field screening and source tracing manual. So the manual is broken up into 5 main sections. The introduction section, which we talked a little bit about the background and the scope of manual and the organization of the manual shown here. We've got a short section on definitions and regulatory requirements. Obviously very important to refer directly to your permit if you have any questions specific to those definitions, but we wanted to provide that in the manual as part of that introductory content. And then really the meat of the manual is sections 3, 4, and 5, which we'll be focusing most of our time on today. The field screening methodologies in section 3, the indicators in section 4, and the source tracing methodologies in section 5. Section 6 are the references, a pretty short section, and then section 7 is new. That's an index. So there's a section at the end that you can use to help navigate your way throughout the manual. And then we have a series of 7 appendices at the end of the manual. And here it is. So we'll be focusing next on the definitions and regulatory requirements, which is section 2. The key updates in section 2 of the 2020 manual are summarized in table 1.1 in the 2020 manual. That includes 2 new definitions, conditionally allowable discharges, which we covered as part of our warm-up exercise today, and also discharge point. We also updated the tables in section 2.2, which include table 2.1, looking at the phase 1 and phase 2 permittee requirements in the 2019-2024 permit. And then table 2.2, the secondary permittees. So secondary permittees are Port of Seattle, Port of Tacoma, and any other secondary permittee included in the Western Washington permit or the Eastern Washington permit. And here's just a quick summary. I put here the phase 2 permit requirements. They're very similar to the phase 1 permit requirements, but here we have kind of our key areas that we're looking at as part of the manual. Our field screening requirements, which are implementing a field screening methodology appropriate to the characteristics of your stormwater drainage system and water quality concerns. We've got field screening methodologies, and here we have a reference to the 2013 ICID Manual, which now you can use the 2020 manual as well, because it's another methodology of comparable or improved effectiveness. We've got our field screening performance measures, which we'll be talking about in just a minute, but that includes field screening for an average of 12% of your stormwater drainage system each year, and tracking the total percent screen starting on August 1st, 2019. And then source tracing, so once you find something, following up on what that is, which can include visual inspections, opening manholes, using mobile cameras, collecting and analyzing water samples, and we'll be talking about a lot of that in detail today. So next we'll shift into section 3. So as I talked about, this is kind of where the bulk of the manual content is, starting in field screening methodologies. Some of the key updates that occurred in the 2020 manual in section 3 include updating figure 3.1, which we'll take a look at in just a minute, adding a new table 3.2, which we'll be talking about in a minute as well, but really that provides some background information on calculating your percent screened, some recommendations there. We shifted 2 BMPs, business inspections and stormwater BMP inspections, to an appendix. So as we were running through the key methodologies, those two seemed like they were less often used for field screening. So that content is still there if you're looking for it. It's just in Appendix E, not in the main text. And then in other field screening methodologies, we added some information for automated sampling. We also added some methodologies that were formerly in the source tracing methodologies section, and those included infrared color aerial photography, infrared thermography, and stream walks. And I mentioned those business inspections and stormwater BMP inspections were shifted to other field screening methodologies. They're still there in the manual, just the content is in an appendix. And we also added canine scent tracking to other field screening methodologies. So the general content in section 3 takes a look at selecting what field screening methodology you're going to be using. And as I mentioned, we'll run through that figure 3.1 in just a minute. It provides some data management recommendations, safety considerations, costs, which is generally a reference to Appendix A, which you can take a look at for more detail in terms of cost for field screening methodologies. And then there's 4 pull-out sections. So what pull-out sections are essentially the manuals broken up. So you can take a look at, if you just want to do catch basin manhole inspections, it's set up so you can just easily pull out that section and put that into your SOPs. So that's the way the manual's broken out. That's why we call them pull-out sections. I've got them in a 3-ring binder, so it's easy to kind of pull them in and swap them out. But we've also provided the Word file for the manual, so you can take that and edit that into your own city or county manual. And then at the end are the other field screening methodologies, which we talked about. So that's just a list of additional field screening methodologies that we didn't go into in detail, but still are valid field screening methodologies that you could use in your program. So next I wanted to run through this figure 3.1. So here you can take a look. This is located on page 15 of your manual if you're looking at the number on the page, or page 25 in the PDF version. As I mentioned earlier, we've got these key field screening methodologies here at the top, which you can also see on the slide. So looking at catch basin manhole inspections, ditch inspections, video inspections, and outfall inspections. And then you need to take a look at whether the flowing discharge is present or not. And then that walks you through the rest of the steps here on what you should do next. And then we'll look at the latter half of the flowchart in the source tracing methodology section. But really this top part here is looking at field screening methodologies and the process that you go through. So one thing to point out here is the 2013 manual had a separate track for pipe systems versus ditch systems, and we've consolidated this into a single flowchart in the 2020 manual just to make it a little more streamlined. So that's one change there. I mentioned earlier this table 3.2, so this is a new table in the 2020 manual. Most of you have probably already started on tracking your annual field screening percentages, but what this provides is just a summary of different ways that you could track these, looking at the different field screening methodologies. So you could track based on number, you could track based on length, or you could track based on area. So that just provides some information there. There's a couple here that say not applicable for length, but what you could do for catch basin manhole inspections or outfall inspections is just use a calculation metric. And there's a footnote on the table in the manual that says basically you could look at, for example, 0.2 miles of linear conveyance could be applied to each catch basin or outfall, but you'd have to look at your system and see what number makes the most sense for your system there. So now walking through the pull-out sections that I showed you, they're set up just to easily pull out and incorporate into your own SOP manuals or other illicit discharge manuals that you have at your jurisdictions. So it starts off with a description of what the field screening methodology is. There's a table that lists the applications, so storm drainage types, whether it's applicable to pipe or ditch systems, land use types, and there's quite a list here, urban, rural, agricultural, commercial. It's got that list there. And then weather conditions. This is a new part of the 2020 manual where we've added, is this applicable in dry or wet weather conditions? There are some caveats there. A lot of illicit discharge field screening is better in dry weather, but you can also do it in wet weather. So you can find that information in this overview table at the beginning of each section. The equipment section is next. So this is something that just helps with planning for your field crews in terms of knowing what types of equipment to take out in the field. It's set up as checkboxes, so you can easily just run through and select what you need out in the field. The pullout section itself is set up in a standard operating procedure format or SOP format, so it really walks you through the different approach and how you go through that for each field screening methodology. And next we have a pros and cons table, and I think this is pretty helpful when you're kind of looking at the different field screening methodologies and determining what would work best for your jurisdiction. So it lists the positive and negative aspects of the field screening methodology, some things you consider when you're deciding on which one to implement. So obviously, nothing has all pros or all cons, so you've got to kind of weigh those things with each other and determine what would be the best. And then the other thing I wanted to point out, there used to be a section in the 2013 manual at the end of each field screening methodology that had a bunch of hyperlinks that kind of navigated you throughout the manual. We ended up removing that in the 2020 manual, and it's been replaced by that index at the very end of the document. So if you're looking for linkages between the manual, go to that section 7 at the end, and that can help you. If you have some idea of what your illicit discharge might be, that could just set you off on the path of what indicators you should look at and things like that. So that's an important thing to take a look at the end. So as I mentioned, we've got these 4 key field screening methodologies. We've got our catch basin manhole inspections, ditch inspections, outfall inspections, and video inspections. They're not set up in priority order. We just put them in alphabetical order. So as you're navigating through the manual, just because catch basin manhole inspections is first doesn't mean that that's the best. We just put them alphabetical and let you weigh the pros and cons when selecting. And then I mentioned at the end is that other field screening methodologies table. And so that just helps if you want to get in more depth in some of these things. There's other things that are out there other than these key 4, but we thought that these were the 4 field screening methodologies to really focus on for this manual. So here again, we've got this table just looking at pipe systems and ditch systems. So same 4 methodologies. You'll notice that catch basin manhole inspections and outfall inspections apply to both piped and ditch systems. And then in pipe systems, you can do video inspections. In ditch systems, obviously, you can do ditch inspections. So there's a couple differences there, but generally a lot of overlap between the field screening methodologies and where they're applicable. So next I wanted to run through each of the main field screening methodologies. I just have 1 or 2 slides on each one of these just to kind of give you an overview of what this is and how you might apply it. So this first one is the catch basin manhole inspections. A lot of you are already doing this as part of your routine O&M. And so this is something that a lot of jurisdictions have decided, hey, this is pretty, low-hanging fruit, something that's easy to implement. So basically what that is, it's looking in your catch basin or manhole, taking off the lid, checking out to see if there's flow there, is there any odor, color, or other visual indicators. Typically works best during dry weather, can also be done during wet weather, but obviously you've got other flows in the system and some of those things may not be as obvious during wet weather. We've got 2 general methods here. We've got a monitoring node approach and a routine maintenance approach that I'll talk about. And if you're following along at home, this is page 21 in the manual or page 31 if you want to navigate through the PDF. So the monitoring node approach really breaks down the storm drain mainline into strategic monitoring nodes or intersections where several branches connect. So here you can see in this example, we've got 2 branches connecting. So if you're noticing here at the bottom, you've got something that's of concern, say you're seeing a weird color or something like that you really want to investigate. You've got these 2 branches that it may be coming from, so you can work your way up the system. So go up branch 1, pop that next manhole. If you don't see it there, then you can go up branch 2, pop that manhole. Then you can kind of narrow down where it's coming from, and you wouldn't have to look at all these manholes in the system to figure out where that's coming from. So it can help you quickly eliminate larger portions of the drainage basins and really focus your on-site investigations. We've also got the routine maintenance approach, which I think is already being implemented by a lot of jurisdictions. So you're out there doing your routine maintenance, taking a look at what the condition of the catch basin is, how much sediment you're collecting, whether they need to be cleaned or not. It's pretty easy just to add some fields to your routine catch basin manhole inspection forms to say that you're taking a look at illicit discharges as well. Some of the things we recommend there include color, odor, turbidity, and other visual indicators, and we'll be covering what those are in more detail. But that could be deposits and staining, floatables, sewage bacteria, things like that you would look for as other indicators. Our second field screening methodology is ditch inspections. This is on page 27 of the manual or page 37 in the PDF version. Again, this is just taking a look at ditches and similar open channels or swales to help identify illicit discharges. So there's 2 general methods for ditch inspections, which include the vehicle foot reconnaissance approach or the routine maintenance approach. The vehicle foot reconnaissance approach is pretty straightforward. So basically just driving the route slowly, stopping frequently to take photographs and record observations of any color, odor, turbidity, visual indicators. You might have auditory indicators of flow, dry weather flow, or other items of interest. And that could be, surrounding land uses and activities. Is there any illegal dumping going on? Any damaged culverts, things like that. So there's a variety of things you might take a look at as part of that. The other approach for ditch inspections is your routine maintenance. This is one that we recently did a project on, looking at ditch maintenance as kind of a overlooked and underfunded part of many programs. But if you're out there assessing your ditches, this is something you take a look at as part of that. So again, if you're out there for a routine O&M inspection, also taking a look at whether you're noticing any color, odor, turbidity, or other visual indicators. And similar to catch basin manholes, just adding that as check boxes on your field form can help check the box on your permit requirements as well. All right, our third field screening methodology is outfall inspections. And what this is taking a look at outfalls to help identify illicit discharges. Those of you that were around for the original permit know that it was pretty focused on outfall inspections, and some jurisdictions found that worked well for them, and others found that they were kind of missing things, and some of these other approaches worked better. So it kind of depends on how your jurisdiction's set up and whether outfall inspections would work for you, how your drainage basins are set up and things like that. But it is a good way to look kind of at the end of the line. Are we noticing any issues there? So taking a look at flow, again, our physical indicators, color, odor, turbidity, visual indicators. And then if you're seeing flow, collecting a sample during dry weather to take a look at that in more detail. And that's located on page 33 in the manual, or page 43 if you're navigating through the PDF. All right, and our fourth field screening methodology is video inspections. And what this is assessing the condition of pipes and structures over a large area of your MS4. This is often done as part of an asset management program, so taking a look at your pipe condition throughout your system. And as part of that, you can also look at your illicit connections and illicit discharges. Generally, illicit connections are fairly easy to find in pipe inspection, just because you're looking at your pipe system and you may see illegal taps or other things coming in that you may not know were there. And other things that you're looking for as part of a video inspection include heavily stained pipes, grease buildup, table scraps. You may see floatables, such as toilet paper or other paper products, soap suds, paint. There's quite a bit you can see when you're actually in the pipe and taking a look at that. And that field screening methodology is on page 37 of the 2020 manual, or page 47 if you're navigating through the PDF. So that kind of wraps up my general field screening methodology overview. Obviously, there's a lot more content in the manual itself, so take a look at that if there's particular field screening methodologies you're interested in implementing, or just want to know a little more about the pros and cons and how you might alter your program to incorporate some of those recommendations. And next, we'll shift into talking about indicators. So this is a pretty large section of the manual, so we'll walk through some of the key indicators that we have included. So some of the main updates that occurred in section 4 in the 2020 manual include streamlining the flow charts, which we'll be talking about in a minute. We've got figure 4.1 and figure 4.2. We added a new section with generic language providing an overview of the various methods used to evaluate indicators. We'll be talking about that in a minute as well. Added examples of conditionally allowable discharges in the flow, pH, temperature, and chlorine sections. The bacteria section had quite a revamp, so definitely take a look at that. We added a lot of detail and updates in that section, and we'll be walking through that in detail today. And then a new indicator that we added was total petroleum hydrocarbons. Previously, it was on the other indicators table, but we moved that up to a follow-up indicator, and so there's more detail included in there for that. And then we added numerous indicators to the other indicators table, and we'll be talking about that at the end of the section today. So here's the general overview of what's in the indicators section. As I mentioned, there's two figures walking through urban and rural land use and how you would go through selecting an indicator. There's a new section on selecting a method along with your indicator. And then there's some general guidance on field quality assurance, quality control, laboratory analysis, quality assurance, quality control, safety considerations, again, always important, and costs, referring you to Appendix A for more detail there. We've got a series of pull-out sections. Here on this slide, we have pull-out section 1 through 8, starting off with flow, and then walking through our other 7 primary indicators. And then we also have additional indicators which are called follow-up indicators. So those start with bacteria and run through our new total petroleum hydrocarbons section. And then at the end, we have other indicators. There's a pretty large table at the end of the section where there's a lot more content there on some potential other indicators you could use. But really, these 15 we have listed here and have included in the manual are the top indicators that are most frequently used. So we provided additional detail on how you would evaluate those. I mentioned there's a new section in the 2020 manual called Selecting a Method. And this includes general overview of information on test strips, test kits, field meters, etc. What that is basically in the old 2013 manual, it had that in each of the indicator sections, and we just pulled some of that generic overview content up to the front of the section. So if you're looking for some general information on how to evaluate these different types of methods, you'll find that now in section 4.2, so that's up front rather than in each of the indicators. And that just streamlines things in the manual, so that content is still there. You'll just be looking in a different place for it. So next we'll be talking about how we select indicators, which is covered in Figure 4.1 and Figure 4.2. As I mentioned, Figure 4.1 is for urban land use, and Figure 4.2 is for rural land use. You can find it on page 45 of your manual and 47 for each figure, and then that's on page 55 and 57 in the PDF version. So generally, this is similar to what it looked like in the 2013 manual. There have been some shifting and things have shifted around. This upfront box here on the thresholds is summarized here on the slide. And basically all of those thresholds are the same. They look at evaluating what would indicate an illicit discharge. So there's various thresholds for various indicators. The only thing that changed in the 2020 manual is adding a centimeter threshold for turbidity, and that goes along with, we added the turbidity tube as an option for measuring turbidity along with a turbidimeter or a visual observation of turbidity. So that 19 centimeters is a new threshold if you're using a turbidity tube for that measurement. And so this looks at the primary field screening indicators, which is this upper box on the flow chart. And then you'll walk through based on your observations where you might go next. So the next set of categories here, if you're noticing that there are some issues or there aren't some issues, you've got these different observation categories. These have been updated in the 2020 manual, and generally they're lumped into 3 categories, which include bubbles or suds, no suds and no sheen, or oily sheen. So those would be kind of your main categories that you take and then walk through the rest of the flow chart after that. So based on those, as you're kind of working down through the flow chart, obviously I condensed this a little bit for the slide here, but bubbles or suds would kind of walk you down to a follow-up indicator, which would be detergents or surfactants. If you don't have suds or sheen, then you're starting off with looking at chlorine or fluoride as one of your follow-up indicators. And then if you're noticing oily sheen, obviously total petroleum hydrocarbons would be a good thing to take a look at next. So those have also been updated in the 2020 manual. And on this slide, I just kind of summarized some of the potential sources. So you'll notice kind of these purple boxes where you end up. And so those provide some potential sources in terms of what might be the illicit discharge once you walk through your indicator measurements. And those have been updated slightly as well in the 2020 manual. And this is kind of the top-down approach, is starting off, assuming that you don't know anything about the illicit discharge, you're following these screening steps, taking a look at these different indicators and kind of working through your results. There's another way to take a look at it as well. If you already have an idea of what you think you might know the discharge is, you could take a look at table 4.1 in the 2020 manual. And so what that is, if you already suspect, well, I know it's construction site runoff, I can see that coming off the site. Instead of following the flow chart, you could just take a look at this table 4.1. Okay, well, I think it's coming from a construction site. Maybe I need to look at color and turbidity as my primary indicators and perhaps follow up with specific conductivity. So again, there's that listed here for concrete slurry, some primary indicators, and gasoline, vehicle oil, or grease. In the manual itself as well, in table 4.1, there's other suspected sources, which include human animal waste, industrial process water, industrial operations, nutrient-rich discharges, sanitary wastewater or sewage, tap water, and wastewater. So this is just kind of a rolled up version, but much more detail in the manual there on table 4.1. So that's kind of the bottom-up approach. I think I know what it is, but I want to have some justification or a number behind that for enforcement. So this is similar to the first slide I showed where we had the 15 indicators. So again, here in the first column, we've got our primary field screening indicators starting off with flow, and then our other 7 primary field screening indicators. So really we're looking at low-cost indicators, things that are easy to sample, things that are just relatively easy to observe or sample out in the field. So things like color, odor, visual indicators. Those are all the pretty quick observations that can be made out in the field. Ammonia, pH, you can get some pretty low-cost test strips or meters to implement those. Temperature, obviously, all you need is a thermometer. So a lot of the things that we put in this column are just cheap, low-cost screening things. And then in the follow-up indicators, here we have more detailed. This could be more expensive equipment, take more time, things like that. So this is something that more detailed indicators, and that's why we put them further down the line in terms of determining what an indicator might be or what an illicit discharge might be. So the pullout sections are set up pretty similar to what we talked about for the field screening methodologies section. Again, we start off with the description. Here in the indicators section, I mentioned some of the indicators have allowable or conditionally allowable discharges where applicable, so there's some new content there up front. Similar to the field screening methodologies, again, we have where the indicator is applicable for storm drainage system types, whether pipes or ditches, land use types, and then weather conditions, again, dry or wet weather. The pullout sections also include equipment. So again, check boxes for the field crews where you'll walk through. This is a pretty comprehensive list, so it kind of depends on what equipment you're actually using or what method you're actually using for your indicator. So some of these may not apply depending on if you're using test strips versus a meter, but it's a pretty comprehensive list along with each indicator. So you can kind of modify that based on what your jurisdiction is actually implementing in terms of the method. Again, we have things set up in SOP format. Here we have for pH, for example, there's a section on test strips and a section on the field meter. So again, you could pick which one you're actually implementing and follow those SOP steps. But the indicator includes both of those, so you can take a look at whether you want to use test strips or a meter. All of that content is there. The one difference in the indicators section is that we have this threshold section, and what that looks at is just a goal that you can use to kind of evaluate whether something might be an issue or not. So they're recommended thresholds. They were based on a lot of literature review, values that other Washington jurisdictions were using, and we also did kind of a nationwide search of other documentation there. We did add a note to the 2020 manual that thresholds may be modified for use based on local knowledge or observations. So you may have some other data where you know what some common levels are in your jurisdiction, so you could definitely adjust those as needed. They're just recommended thresholds. We also included the surface water quality standards if applicable. They're for reference only. They're not intended to be thresholds in storm drainage systems. We just provided them as kind of a baseline point. You'll notice for pH, for example, the IDD thresholds that we picked for evaluation are different than the thresholds that you would use for surface water quality because we're generally not in the surface water quality system unless you're at the outfall. A lot of times you're taking a look in a catch basin or a pipe, so you wouldn't be meeting those surface water quality standards in the pipe or catch basin. We also have pros and cons. So again, similar to the field screening methodologies, we've got the pros and cons of each indicator, and along with that also the pros and cons of each method that you might select. So test strips versus field meter, what are some pros and cons of selecting those different methods to evaluate your indicators? Another section that I kind of like in the indicator section is the common sources table, and this was kind of a fun one to pull together. So a lot of literature review, a lot of research on what some typical sources of these things might be. Here, for example, in pH, we've got our both low pH and high pH are a concern. So what are some common sources of low pH? What are some common sources of high pH? And how would we evaluate that in terms of an illicit discharge or illicit connection? So again, here's our list of primary field screening indicators, and we're going to walk through each one of these today. Generally, if flow is observed, then you would look at the next 7 primary field screening indicators on this list. So let's start off with flow. This is something you take a look at whether it's observed during dry weather or whether it's observed a lot of times during wet weather. We're going to have flow obviously in our systems, but during dry weather, if you're seeing flow, it's kind of questioning what is that, where is it coming from, is it just groundwater, is there something else going on here? So is the ditch conveying natural flow, is it continuous, intermittent, or transitory? So that's one where you could take a look at. Section 2 provides definitions for each one of these. But generally, continuous discharge is something that occurs most or all of the time. Intermittent is something that occurs a few hours per day or a few days per year. That could be a cross connection to a washing machine in someone's basement where you're just getting an occasional discharge, but not all the time, or a commercial dumping type of discharge, or a swimming pool discharge. We talked about that as part of the warm-up exercise. But if someone's discharging their swimming pool, that's something that's intermittent. It's something that doesn't happen all of the time. And then transitory, this is kind of the trickier one to figure out what's going on. Transitory is something that occurs in response to a singular event. That could be a vehicle accident, that could be illegal dumping, sewer main break, things like that, a ruptured tank. So things that are just transitory or only occur for a brief amount of time in response to a specific event. So determining what the flow is and what it's caused by kind of will help you set your investigation priorities and the next steps that you move through. So walking through our list, again, I mentioned we kind of did things in alphabetical order, so it doesn't mean ammonia is your top indicator. It's just out of the 7, it's the one that comes up first in the alphabet. So this is on page 63 of your manual, or page 73 in the PDF version. Most of you are probably familiar what ammonia is, but generally it's produced by decay of organic nitrogen compounds. If you detect it, then the source is fairly recent because it breaks down over time. And here's just some common sources of high ammonia. That could be a result of sanitary wastewater, septic system discharge, could also be fertilizers or pesticides, manure, or industrial or commercial waste. So taking a look at what some potential sources are of ammonia. Next we have color, which is kind of a fun section to put together. This is just a rolled up version of what's in the manual, but definitely take a look at those tables. There's lots of photographs in there to help you identify what some different illicit discharges might be and what some potential sources are. So this starts on page 69 in your manual or page 79 in the PDF version. And this just provides a list. Obviously some of these are pretty obvious if you're seeing dark red or purple. That's pretty striking, probably not something you see very commonly in stormwater. That could be blood from meat processing or packing, fabric dye, heating oil, paint, paper ink. There's a variety of different things here where you can take a look at your surrounding land use and where might that be coming from. So some different ideas there on how to follow up and determine what some of these sources are. Similarly, in the odor section, which is on page 75 or page 85 in the PDF version, again, this is a rolled up version of that table. It's pretty detailed, but some common odors and what their potential sources might be. So here we've got, the rotten egg smell that's pretty typical of raw sewage or sulfuric acid, stagnant water. We added some to this list as well. We've now got, beer, wine, alcohol, yeasty, that could be discharges from a winery or brewery or distillery. And then obviously we've got our, things that smell like gasoline, oil or spill, leak, or vehicle maintenance, things like that. So a pretty comprehensive list. Obviously, both color and odor, it's not everything you may find, but a good summary of what some potential sources might be. Our next indicator in the manual is pH. So this is measuring hydrogen ion activity on a scale from 1 to 14. And as I mentioned earlier, both low pH and high pH is a concern for water quality and for investigating illicit discharges. So you can find this on page 79 in your manual or page 89 in the PDF. And here's kind of a range of some of the different things that you might find for high and low pH. And along with that, here's just a summary that I showed a few slides back, but it was a little bit smaller. So here's looking at low pH. That could be dairy products, fertilizers and pesticides, wineries. High pH could be things like latex paint, metal planing, poured or recycled concrete. That's one you'll see pretty commonly with construction sites, and soaps and detergents as well. Temperature is our next indicator. This is on page 85 in the manual or page 95 in the PDF version. This is one that's most useful in cold weather when the temperature difference is significant. This is one that we found working with some Eastern Washington permittees. This was one that actually came up as something that worked well in Eastern Washington on those really cold winter days. You could see kind of that warm water kind of coming out of your storm system, and something's going on there. So that warm water temperature during cold weather may indicate sewage or industrial cooling water, and then you can follow up and investigate that. The next primary indicator we have is turbidity. This is one you're probably familiar with, but essentially it's a measure of how transparent or clear the water is based on the amount of sediment or suspended particulates. A lot of times we see that caused by construction activities, landscaping activities, soil erosion, etc. So there's a variety of different things. You can see here in the picture pretty obvious, erosion or turbidity coming off of a vegetated area here. That could be found on page 89 in your manual or page 99 in the PDF version. One thing to note is I mentioned earlier that we added turbidity tubes to the 2020 manual. So if that's something you're interested in using or you already have that equipment, there's now a new table in there that helps you convert your centimeter measurement to what would be NTU measurement. And our last primary field screening indicator is visual indicators. So this one I have a couple slides on because there's a lot that you could find there. Some of the key things that we have summarized in this section, which starts on page 95 of your manual or page 105 in the PDF. And if you're interested in the photos, you can flip ahead a few pages. That starts on page 98. There's some pretty good tables in there with a bunch of photo examples. Here we've got abnormal vegetation as one of our items. So that could be either excessive vegetation or absence of vegetation, and both are a concern. If you've got a lot of vegetation growing, that means there's some extra nutrients and things coming in. That could be an issue. And if you've got just dead vegetation at your outfall, then the absence of vegetation is a concern. You may have some things coming in that are industrial sources that are causing that vegetation to die. One thing to point out here, though, if it's the middle of the summer, you might expect some of that vegetation to be dead, so you gotta kind of weigh it based on time of year as well. Deposits and staining are a good one to look at, particularly in outfalls and catch basins, because you may have a source that's left something behind and you still see that on the side of the catch basin or on the side of the outfall, and that can be a concern. Fish kills, obviously that's one that we're concerned about if you see that happening. Floatables. This is one that it seems like kind of obvious if you're seeing floatables, but it happens quite a bit. This photo here is maybe kind of hard to see what's going on here, but we've got, it's green because there was some dye testing to confirm the illicit connection. But I don't know if you can see there, toilet paper and other floatables in the catch basin. So there's an issue there. If you open up your catch basin and it looks like that, you know you've got some issues with illicit connections there. Some other things you could see that we've heard from other jurisdictions, you know, food products, leftovers from food processing, obviously oils, fuels, and solvents and things like that. So there's a lot you could see just visually in the floatables category. Fungus and algae is the next category. So there's a couple of photo examples here and some great ones in the manual that came from King County. We've got a variety of different types of fungus and algae that you might find. Generally this white or grayish growth in floating water. That could be a result of a sewage or a wastewater treatment plant discharge. It kind of breaks up into nothing when you touch it with a stick, and it disappears quickly after the sewage discharge goes away. So that's a good indicator for sewage. We've got this dried white mat-like growth residue, and that's kind of a combination of fungus, algae, organics, and detritus. It's like this thin, dry coating on a solid surface. We've got green or brown algae growth. That could be, you know, a natural phenomenon, but as I mentioned earlier, you know, if you're seeing a lot of growth, there might be some other nutrient sources that's causing that to occur. All right, that was our last field screening indicator, or primary field screening indicator, and now we're going to shift into a follow-up indicator, which is bacteria. This was one section that was updated pretty substantially in the 2020 manual update. Instead of being fecal coliform bacteria like it was in the 2013 manual, we expanded it out to include other types of bacteria, including E. coli, Bacteroides, and Enterococcus. So fecal coliform and E. coli are commonly lumped together, and they're typically used as indicators of fecal contamination of stormwater and natural waters, and they're present in the fecal waste of warm-blooded animals. So they can be used as an indicator of human waste or animal waste. Bacteroides is commonly used along with microbial source tracking to take a look at, also called bacterial or fecal source tracking, and that can be used to track down and confirm suspected sources of human waste and other kinds of animal waste as well. And Enterococcus is primarily used in marine water bodies, and so it's not commonly used as an illicit discharge indicator, but we did include it here to be comprehensive and take a look at all the different types of bacteria. And here's a table summarizing the thresholds that are included in the bacteria section, and these have been updated in the 2020 manual, and also bacteria thresholds added for the other types of bacteria that are now included in this section. And they include recommended ranges because bacteria is highly context specific, and the results can be influenced by other factors such as weather, seasonality, antecedent dry or wet periods, and sampling location characteristics. So what the type of land use is, if there are septic systems present, formal or informal drainage areas. So that's why we decided to include ranges rather than absolute threshold values here. I also wanted to note that, again, Enterococcus is marine water specific. It's not commonly used in freshwater, but we did include it here to be comprehensive. And the Bacteroides threshold does vary based by biomarker, extract volume, and analysis method. So it's best to follow up with your analytical laboratory and determine what the best threshold value is to be used there. So here we do have ranges for E. coli and fecal coliform. And the Bacteroides is one that we couldn't really determine an exact number for, so you'll want to follow up with the lab that's doing your analysis and see what threshold value they recommend in that case. And then our next follow-up indicator is total petroleum hydrocarbons. I mentioned that this was one that used to be on the other indicators list that we shifted forward to the follow-up indicators list. It's something that comes up quite a bit with all the oil drips and spills and leaks in this area. So that's really what it is it's a family of several hundred chemical compounds, primarily composed of hydrogen and carbon, or what we call hydrocarbons, that originate from crude oil. So that can include various things such as benzene, toluene, xylene. A lot of these things you've probably heard of before. It's all kind of lumped together in this TPH measurement. And in Washington, we do this laboratory analysis called NW-TPH, and it groups compounds into a diesel fraction, motor oil and diesel, and then a gasoline fraction. So we've got the DX and the GX components. So this is something that we looked at, and we added a new threshold for that, which was 1 milligram per liter of either the DX or the GX fraction for that further investigation threshold. And the TPH section starts on page 135 of the manual, and that's page 145 in the PDF version. I mentioned that our other indicators list is pretty long. Obviously, with surface water quality indicators and water quality indicators, there's so many things you can test for. So we took a look at, what are some other common sources, things that people are using for indicator sampling. And so here we expanded this list, and we added 7 new indicators here, bolded in orange. So we added things like caffeine, chemical oxygen demand, fecal sterols, fluorescence, pharmaceuticals, oxygen-stable isotopes, and salinity. Some of these are not as commonly used, but all have been used in some sort of illicit discharge or illicit connection sampling, so we wanted to include a more comprehensive list. The other one you'll notice, potassium used to be one of our follow-up indicators. It's now shifted to the other indicators list, so the content for that indicator can now be found in Appendix F. So that's just a summary of the new other indicators that are listed there, and there's a quick little summary along with each one of those indicators. All right, so that wraps up our indicator section, which was section 4 of the manual. And next we'll shift into section 5, which is the source tracing methodologies. It's our last major section to highlight today. Some of the key changes in section 5 of the 2020 manual include shifting optical brightener monitoring and sandbagging from the main text to Appendix G. We also added some example questions for neighboring homeowner or business owner or employee interviews that may be useful to you. And in the other source tracing methodologies, we expanded the continuous monitoring description, and we also added the optical brightener monitoring and sandbagging that got shifted to the appendix, as well as pressure testing. And I mentioned earlier that we shifted the infrared color aerial photography, infrared thermography, and streamwalks to section 3, the field screening methodology table. So we added 3 and shifted 3. So again, the structure of the source tracing methodology section is pretty similar to what we looked at for the field screening methodology section. It does refer you back to that figure 3.1 in section 3, which is the field screening and source tracing methodology flowchart. Again, we have data management recommendations and safety considerations and a reference to the cost appendix, which is Appendix A. And here we have a total of 8 pullout sections. We have 4 listed here on this slide. We've got business inspections, catch basin manhole inspections, ditch inspections, and dye testing. And then on the next slide, we've got our septic system inspections, smoke testing, vehicle foot reconnaissance, and video inspections. So again, you'll notice alphabetical order, not in priority order, but you can go through and pick the ones that work best for your jurisdiction. And then at the end, we had that other source tracing methodologies table. And here we have a photograph of some smoke testing, and we've got different colored smoke candles here used in a manhole for source tracing. So shifting back to that figure 3.1 that's in section 3, now we're going to the bottom of the flowchart here. So take a look at your manual for this. All the way to the bottom here, we're back to page 15 in the manual or page 25 in the PDF version. And the bottom portion is where you're looking at your source tracing methodologies. So here on the slide, if we've got visual or olfactory observations that suggest a potential illicit discharge, and we do not have standing water present, then we'll probably be looking at ditch inspections, sandbagging, or video inspections. If we're conducting indicator sampling and those results suggest a potential illicit discharge and we have access to the property, we'll be looking at catch basin manhole inspections, dye testing, septic system inspections, business inspections, or one of those other source tracing methodologies. And then if we do not have access to the property, your options can be looking at vehicle foot reconnaissance, smoke testing, although you would have some notification that would go along with that, video inspections, ditch inspections, or one of our other source tracing methodologies. So here's the full list of 8, and you'll notice the ones here highlighted in orange are the ones that we haven't covered yet. There are 3 that kind of overlap between the field screening and the source tracing sections of the manual. So there's some minor revisions. Those are repeated in the source tracing methodology section because there are some differences in how you would apply catch basin manhole inspections, ditch inspections, or video inspections for source tracing. But since we've already covered those today, we're going to focus on these ones highlighted in orange here. So the first one that we'll talk about is business inspections. Most of you are probably familiar with this through some of your local source control inspections or providing spill kits to businesses. But during a part of those inspections, you can also take a look at detailed investigation of potential cross connections, illicit discharge sources from materials stored or used at a business or private property, and really focusing on source tracing. You've already identified that it might be a set or a subset of properties that you want to do this further business inspection as part of. So it's kind of triggering what you're seeing in your catch basin or manhole or ditch or outfall that would then point you towards specific properties to do a more targeted inspection. And you can find that content on page 149 in the manual or page 159 in the PDF. The second source tracing methodology that we're going to highlight today is dye testing. So this is one that's pretty commonly used. It's used to pinpoint or isolate illicit connections in a smaller section of the storm drainage system. You can also test storm drainage system or plumbing fixtures at an individual facility. So you could go into a building and test all the toilets and sinks and things like that. As we mentioned, commonly washing machines and basements are a common cross connection. So something like that, you could test those different types of systems. There's a lot of different types of dye available. So in the manual, there's kind of the pros and cons of dye testing in general, as well as the different types of dye that are available. You could get them in liquid, powder, strips, wax cakes, cones, and donuts, or tablets. And there's different pros and cons to each of those and situations where they work best. That's on page 161 in the manual or page 171 in the PDF version. The next source tracing methodology we wanted to focus on today is septic system investigations. This is on page 167 in the manual or page 177 in the PDF. And there's 3 main methods here that we wanted to highlight. We've got our homeowner interview and yard inspection. So just some simple questions and taking a look at the condition of the yard. We've got our detailed system inspection where you've typically got a septic system inspector that would do that and has education to know what to look for. And then we've also got canine scent tracking. So that's kind of an interesting one to take a look at. But there are those sewage sniffing dogs out there that can help us out in these situations. So if you have access to that, that can be a good way to find some of those discharges or connections. Our next source tracing methodology is smoke testing. And so what this is it involves forcing a non-toxic artificially created smoke through the storm drainage system using a smoke blower or a fan. And that can help find leaks and illicit connections to the system. So this is definitely one that requires some pretty extensive notification to the public. Obviously, you're having smoke possibly coming up at people's houses and the sewer stack air vents and things like that. So here, this picture you can see in Federal Way, they've got the smoke coming out of all their various catch basins here along this stretch of road. So some extensive outreach needed to let people know that that's going on, but it can be useful if you want to test a large system all at once. And that can be found on page 171 in the manual or page 181 in the PDF. And then our last source tracing methodology that we wanted to highlight today is vehicle foot reconnaissance. This one's pretty straightforward. It pretty much is what the title is, but that's really driving, which can be done more in a field screening section where you're trying to cover large areas, or walking in the source tracing setting where you're looking at a smaller, more focused area where your discharge may be coming from. So you're investigating specific areas when they're narrowed down to a smaller area or property or set of properties that may have an illicit connection or illicit discharge. This example here from the Center for Watershed Protection Manual, they were seeing this soapy discharge in the stream and they were driving around the drainage basin, and here they had a laundromat. So they were able to connect that this source in the stream may be from something in this drainage basin that we want to investigate in more detail. And information on that can be found on page 177 in the manual or page 187 of the PDF. I've got one slide just highlighting the changes in the appendices. So the costs were updated to 2020 costs, and so there's updated costs throughout Appendix A that you can take a look at. There's also some new equipment that we added in the manual that also got added to Appendix A. One thing to keep in mind for the costs is those always fluctuate. We've got general links to some of the websites, but it's not a fully comprehensive list, or it's not a list of recommendations that, these are the only things you can use. There's a lot of information out there. It's just included as a ballpark to help estimating cost for the different methods, and something that you might want to put together as a full package for your illicit discharge program. Appendix B, example field forms. We added 2 new example field forms, and we removed 1 outdated form, so just some minor changes there. Appendix C, no changes. Appendix D, we added and updated some resources. Appendix E is the other field screening methodologies. And so that's a new appendix that includes the business inspection and stormwater BMP inspections for field screening. So that was content that was formerly in the main text that got shifted to an appendix. Appendix F is our other indicators, and that just includes the potassium indicator that used to be a follow-up indicator, but now is an other indicator. And then Appendix G is our other source tracing methodologies, and that's where the optical brightener monitoring and sandbagging information got shifted. So we wanted to make sure, even though we were kind of deprioritizing those methodologies and indicators, that we didn't lose that content. So if that's something that you still want to use, it's still available. It's just at the end of the manual instead of in the main text. So that's kind of our recap, our overview of the manual. So hopefully that gives you a good idea of what content is in there, some resources and ideas, things you might want to look into, how you might use that and integrate that into your program. So having those easy pull-out sections that can be integrated into your IDED program documents or your own SOP manuals. So hopefully with the training today, you can now recognize the illicit connection and illicit discharge field screening and source tracing guidance manual, or the ICID manual, and also know how to apply the ICID manual in your program. All right. So that's a summary of what's included in the illicit connection and illicit discharge field screening and source tracing manual. If you have any questions on the manual, the contact information is provided here for the lead agency, which was King County with Jeannie Dorn, and the consulting team, which includes James Packman from Aspect Consulting and myself, Rebecca Dugopolsky with Herrera Environmental Consultants. There's also lots of great information available on the Washington Stormwater Center website, where you can download the full version of the PDF manual. Hopefully you've taken a look at that already prior to this training, but that's available there, as well as the Word file of the full manual. You can take pieces of that and incorporate that into your own documentation, whether that's an illicit discharge documentation for your whole program or specific to your SOPs. You could also download some of the Appendix B field forms and incorporate those into your program. There's also links to a wide variety of instructional videos that focus on field equipment demos for many of the indicators and a few of the source tracing methodologies, and also some information on proper field sampling technique in surface waters, as in catch basins and manholes. Thanks for listening to our manual overview today. We hope that you learned something and you can take that and incorporate that into your own programs. As I mentioned, there's lots of resources available, and so hopefully those can benefit your programs and help you out in your future permit compliance. Thanks for joining us.